for these ones, I think we're at the point where you should be trying these on your own. So write this down, pause the video, see how far you can get, and then play the rest of the video. And maybe you found another way to make this work. Maybe you got stuck, but you won't know until you try. Alright, so I am going to work on this side because this is definitely the more complex side. And I'm seeing the squareds, so I'm thinking about those Pythagorean identities. Let me write out the two that I'm going to use, and that would be 1 plus tan squared x equals secant squared x. I'm gonna, actually, that one's set up and ready to go, so I can replace this with this. I don't have to move anything around, so that's simple enough. Secant squared x. Sometimes we have to move them around before we work with them. The other one is sine squared x plus cosine squared x equals 1. Well, I need to plug some of that in here, and I can move this around until I get cosine squared x minus 1. I can't actually substitute in completely for the 1. There's a lot of different ways to go about this, but you should get the same answer no matter what. Just be careful that you don't miss a plus or minus sign, because you can easily kind of accidentally change the sign on one of these. Alright, so let's see here. I'm going to plug it in the way it is. Now I'm going to move it around. Okay, let's see. I'm going to get cosine squared x minus 1. So I'm going to bring the 1 over to make it a minus 1, and then I'm going to bring the sign over there to make that negative. So sine squared x plus cosine squared x minus 1 equals 0. Now I'm going to move the sign. So cosine squared x minus 1 equals negative sine squared x. And now I can do the direct substitution. Right there, negative sine squared x equals negative tangent squared x. And I'm going to rewrite secant in terms of sine and cosine, which secant, if you remember, is 1 over cosine. So 1 over cosine squared x equals, times negative sine squared x equals negative tangent squared x. I can't put these together, so negative sine squared x over cosine squared x equals negative tangent squared x, and there you have it. Because sine over cosine is tangent, the negative sign came from there. And that's about it. All right. Let's just keep on trying them. At any point, if you're like, you know what, I've got this, by all means, just start working on the sample problems. That's fine. But the more, I'm just going to keep posting more of these because they're just all different styles, and it'll be helpful just for the continual practice. All right, let's do another. Secant y plus tangent y equals cosine y over 1 minus sine y. All right, so anytime you have a fraction, typically that would be the more complex side. So I'm going to work with the right side, and I'm going to do what I did in the last video. I'm going to get rid of, I want to get rid of this denominator. I need to get it into being a monomial. I don't want a minus sign there. And I'm going to do that by multiplying by the conjugate pair. So 1 plus sine y will make that cancel very nicely. The top, I'm just going to leave it, I'm not even going to multiply it out. I will eventually. I'm going to leave it for now, though. Cosine y, 1 plus sine y on the top. On the bottom, 1 plus sine y minus sine y minus sine squared y. And on the bottom, just like always, those middle terms will cancel out. to 1 minus sine squared y. And we've done this substitution before. Let me write this down again so you can remember. Cosine squared y plus sine squared y equals 1. So I'm just going to substitute right here. 1 is equal to this. I'm going to plug in the whole thing. I'm not going to move it around like I have before, but you can see that's still going to work out to be the same thing. You know what, while I'm at it, I'm going to distribute the top. I have to do it eventually anyhow. So you see, if I do it that way and I substitute in for the 1, which I can do, it's still going to cancel out. It's still going to work out like I wanted it to. Here goes the sine squared y's. They're gone because it's a plus and a minus. So now I have, it's this only over just cosine squared y. So I'm actually going to split up the cosine squared y underneath that and underneath that. Secant y plus tangent y equals cosine y over cosine squared y minus sine y cosine y over cosine squared y. I could do some reducing and then simplifying, and this one's going to work out nicely in like 2 more steps. So secant y plus tangent y equals, that's cosine over cosine squared. That's going to reduce to 1 over cosine y. Right here, this cosine will cancel with one of these cosines, so minus sine over cosine. And I can see that 1 over cosine is secant, and sine over cosine is tangent. Oops. I made a mistake. I see that that's a plus, so this should have been a plus. This should have been a plus, and that should have been a plus, and now it works out perfectly. All right, I have one more to do, and then I'm going to give you the sample questions to try. Okay. So this one's a little bit different, just because neither side is better than the other, so we're actually going to work on both sides kind of at the same time. Or one at a time, it doesn't matter. Okay. Cotangent squared theta over 1 plus cosecant theta equals 1 minus sine theta over sine theta. Are they equal? Yes. We've got to prove it. All right. So I'm going to work on the left side first. I'm going to, I see the squared, and right away I'm thinking about the Pythagorean identity, and I know that it is 1 plus cotangent squared theta equals cosecant squared theta. So let me move the 1 over, and I'll have cotangent squared theta equals cosecant squared theta minus 1. And let me do the direct substitution. This equals that. So cosecant squared theta minus 1 equals 1 plus cosecant theta. All right, now this is factorable on the top here because it is a difference of squares. So cosecant theta plus 1, cosecant theta minus 1 over 1 plus cosecant theta. And I see that this is canceling. So this whole left side should simplify to cosecant theta minus 1. Now let's kind of pause there because I'm not sure what this side's going to work out to be. So let's kind of just see what's going to happen with this. And let's see if we can get it to equal the same thing. All right. Here, I am going to See, if this part with the minus sign was in the denominator, then I do that whole conjugate pair, I do the 1 plus sine theta. But because it's just a single monomial, there's no plus or minus in the denominator, I can actually split up the sign and put it underneath each of these. And that's a lot different and a lot simpler. So 1 over sine theta minus sine theta over sine theta. And that works out really nice because 1 over sine theta is cosecant theta. And sine over sine, of course, is just 1. There it is. So the right side was a lot easier than the left side. All right. I think we've practiced enough. I'm going to pick a handful of questions. I'm going to pick odds, of course, for you so that you can try them on your own and check your answers. So, page 367. Let's see here. I'm going to give you let's see. Let's do number 3, number 5, number 13, number 23. Trying to pick a few of each. Let's go with 25. And 33. That should be a little bit of everything. Try them out. If you get stuck on any, of course, send me a message and I will do them for you and send them back out. Thanks.